Welcome viewers. So, now I would like to share a discussion with you on the course that I am going to offer, metal cutting and machine tools. Basically, metal cutting is a way of giving shape to bodies by removal of material, and this has a very wide application through different manufacturing industries. For example, lathes, milling machines, shapers that you hear of, all these things belong to metal cutting machines. So, metal cutting can be done basically by the application of mechanical forces with sharp cutting tools, and almost different aspects of metal cutting will be covered in this particular course. For example, we will start with geometrical analysis of these metal cutting tools. For example, the tools which are used on the lathe, tools which are used on drilling machines, that means drill tools, milling cutters, grinding wheels, etc. All these are different types of cutting tools, and we will have a discussion on their geometrical features. For example, what kind of tool angles do these cutting elements have, and why they have it, and what are the mathematical calculations in order to obtain these values, what are the ways in which we can convert one system of tool angles and that is one system of tool nomenclature to another system of tool nomenclature, what are the angles that we should be concerned about if we want to grind these cutting tools, etc. All these aspects we will be discussing in great detail. After that, we will be studying the mechanism of chip formation and the cutting forces which arise in case of metal cutting. Chip formation means that the excess material which is removed from a blank or an initial body so as to obtain a definite shape and size. This excess material comes out in the form of chips. That means, we give a name to that excess material coming out in the form of chips. So, we will be studying the mechanism of chip formation, and after that we will be studying in detail the cutting forces which arise during metal cutting. Why are these important? Because they help us in designing the cutting tool, in designing the machine tool, in finding out ways by which we can reduce these cutting forces, because cutting forces, if they arise, they are going to increase the power, they are going to deflect material, they are going to create inaccuracies in the job geometry. So, we will try to by studying cutting forces, we will ultimately try to find out ways of reducing cutting forces. After that, the other detrimental effect of metal cutting is the wearing and tearing of cutting tools. That means, cutting tools, if used, even if they do not break, even if they are not destroyed by some catastrophic process, they will be undergoing wear and tear, due to which they will be getting dull over time. That means, we would have to either employ new cutting tools, or we have to grind, that means polish those cutting tools which have become dull, and this whole process of wearing of cutting tools and finding out the effective life of a tool will also be studied under wear of cutting tools and tool life. So, that also we are going to study in detail. Next comes the study of cutting temperatures. That is, tool temperature rise is also a detrimental factor, especially in, say, processes called grinding, and we are going to study these aspects as well. So, this is mainly the studies centered on the cutting tool, and after that we are also going to study in detail about different types of machine tools like lathes, milling machines, drilling machines, grinding machines, etc. So, that way we will understand what are the different parts of these machines which are essential in carrying out the different types of functions these are supposed to carry out. And so, machine tools will be studied also in detail, and after that there are some aspects like upcoming aspects which will be studied by us. For example, we will have an overview of the non-conventional processes, we will have an overview of developments of control systems on cutting tools, for example, automatic machine tools, then special purpose machine tools, cam controlled machine tools, that means fixed automation, and also CNC machine tools. Okay. CNC stands for computer numerical controlled machine tools. That means use of computers in order to control machine tools. So, last of all, we will also touch on certain recent developments in the process like rapid prototyping. That means machines which allow us to carry out rapid prototyping, etc. And other recent aspects like how to cut very complex surfaces, how to cut curved surfaces, etc. Those also we are going to study. So, in all, this particular subject is going to be, first of all, it is going to be maths based. That means that as much as possible we will try to focus our attention on the study of the mathematical aspects of different processes and the solution of numerical problems. This will help in the long run for the students to cope with numerical problems which will be coming in different examinations, especially competitive examinations, etc. So, we will definitely cover theory, but we will back it up with the solution of numerical problems, and weekly assignments will be containing a number of numerical problems, and before weekly assignments have to be submitted, there will be sufficient number of problems which will be worked out during these lectures. So, basically we are going to cover cutting tools, geometry, chip formation, cutting forces, wear of cutting tools, tool life, tool temperature, and on the machine tool side we are going to have basic a description and categorization of machine tools, lathe, milling machine, drilling machine, grinding machine, and then upcoming subjects rapid prototyping, then other developments like automatic machines, computer controlled machines, and finally a number of solutions of numerical problems. Thank you.